stall. So anyway, for this problem here, 8 feet 11 inches times 9. So we're going to do 9 times 11 is 99 inches. Of course, that can be adjusted to be, how many feet can I get out of that? 8 feet is 96 inches. So how many inches are left over? 3. So we will keep the 3 inches and carry the 8 feet. 9 times 8? 72. Plus 8 is 80. So 80 feet, 3 inches.
I got another 9 feet. That's pretty good.
Another 9 feet? A little extra?
Yeah, a little extra.
No extra charge? So here we're going to go 11 into 36 feet. Well, 36 feet, 8 inches divided into 11 equal pieces. 11 goes into 36. 3, so that's 3 feet. 3 feet times 11 is 33 feet. We subtract to get 3 feet. Before we bring down the 8 inches, what do we have to do? Convert the 3 feet into 36 inches. And then bring down the 8. 8 plus 36 is 44 inches divided by 11. 4 inches. So 3 feet, 4 inches.
I converted it all into inches. And then brought it back to it.
That works. Convert it all into inches. Divide by the 11. Get 100 or get 40 inches. That works. Okay. Did you guys get all those problems done on the front page of that packet?
Yeah.
Okay. I guess that was actually, we went over those last week already, didn't we? We had stuff out of the other packet for machine tool.
I get all the way through 26, but I realized it's going too
Only go to 16. Well, you're 10 problems ahead for today's assignment. Okay, so today we want to talk a little bit more about those ratios. I mean, we had some pretty nasty ones in there where we had things like, 1 3/4 to 4 1/5. And you're asked to reduce that ratio. What did we have to do to reduce that ratio? Not necessarily. But there's a reason why I write it as a fraction. I mean, the book might have written it like this, 1 3/4 to 4 1/5. There's a reason I write it as a fraction, because it tells me mathematically what to do. It's division. Fractions are division. So I'm going to divide that. 1 3/4 divided by 4 1/5. Because remember, a ratio has to be a comparison between two numbers, and it's easier if those are two whole numbers, or integers at least. So now to divide that out, I have to turn them into improper fractions. 1 3/4 is 7/4. Divided by 4 1/5 is how many fifths? 21. Now to complete that division, I keep the 7/4, and I'm going to invert and multiply. So I'm going to take the reciprocal of 21/5, which is 5 over 21, and I'm not dividing, I'm multiplying now.
You invert something, you have to multiply, right? You invert
Well, dividing by a fraction, you multiply by its reciprocal. So now I'm going to cross cancel the 7 and 21 to give me 3 and 1.
So if it's a multiply, you can divide by the reciprocal.
You could divide by the reciprocal if you wanted to, but there's very few cases where that'd be beneficial for you. 1 times 5 is 5. 4 times 3 is 12. So it's a 5 to 12 ratio is what that is. Make sense? No, that's not actually one of the problems in there. But there were several that were fractions in there.
If you wanted to do, I just made that one into 1.75 divided by 4.2.
That could work out. Then you get like 0.4. Yeah. But then you want to get those decimals out of there too. You don't want to have decimals in your ratios either. And there are a few cases where you'd want what they call a unit rate, where you would divide it down to 0.4 blah 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 over 1 or 2/1. But in most cases, you want to leave them as whole numbers. Any problems off the homework that you want to see done?
I'm not sure about 9 and 10.
Okay, what are the numbers there? What are the numbers ahead on 9 and 10? I don't have a packet.
3a squared.
3 squared b by 9ab.
No, 3
Oh, 3a. Got it. 3a squared b over 9ab. Like that. We didn't do a whole lot with variables like this last semester. Of course, the 3 and the 9 can be canceled and be a 1 and a 3, right? I'm not going to put the 1 up top because I don't need it. A squared and a can be canceled. Think of this as a times a, so I can just cancel out one of the a's. The b can cancel out, so it's just a to 3. We're not going to do any ratios or letters to variables to numbers, but yeah, I just cancel it out like you would any fractions. Factor it out. And remember when we did fractions, if I have something like, well, what do I want to put up here? Let's do 45/60ths. One of the ways you can reduce that fraction is to factor it. 45 is 3 times 3 times 5. And 60, 2 times 2 times 3 times 5. Then you just cancel out common factors. Cancel out a 3, cancel out a 5. You're left with 3 over 4. There's 3 on top, and 2 times 2 makes 4 on bottom. So you could just divide by 15, but this is just one way of doing it. When you run into a fraction like this, do you see that you could divide both of those by 3ab? A lot of times you don't. So you just factor this out. This is 3 times a times a times b. This is 9 is 3 times 3 times a times b. And now you see I can cancel out a 3, I can cancel out an a, I can cancel out a b, and I'm left with a over 3. Make sense a little bit? Well, let's take a look at our new stuff here quick. Not terribly new because it's stuff we did a little bit last semester when we were talking about percentages. We solved these proportions. And we talked about it a little bit last week. If I have something like 7 over 9 and I want to know that is the same as 35 over what? How do I find x? Okay, that's one way to do it. You can say, well, this was 7 times 5, so this has to be 9 times 5 to make x. 7 times 5 is 35, 9 times 5 makes 45. That's one way to do it. Another way, if you didn't see that that was 7 times 5 to make 35, was to, cross multiply and divide. 9 times 35 then divided by 7 would be root 45. The reason we do this is a lot of times it's difficult to see what you're multiplying both of them by. Because you might have 8 out of 20 equals what out of 70? Well, what times 20 equals 70? If you look really close, you find it's 3.5. But it's then times 8. And that really is what we're doing. 70 divided by 20 and times 8. We're just changing the order. We're doing 8 times 70, then divide by 20. It's, you're still taking the 70, you're still multiplying by 8 and dividing by 20, but you're doing the multiplication first. Which ends up being 28. But what we're doing there is really just a shortcut. What we're really doing there is this. Cross multiply and divide, as we mentioned, is a shortcut. In a fraction, the cross product, or in a proportion, the cross products have to be equal. 8 times 70 is 560. That has to equal 20 times x, or 20x. And we're doing those cross products, and what we're doing is setting them equal. 20x equals 560, and then you're dividing by the 20. X equals 28. But what we notice is when we solve this equation here, what we're doing is dividing by 20, which is the number that's on the diagonal with our x. So rather than doing the cross products and writing out the equation and dividing it out, we take that shortcut. We know that we're going to multiply these two to get that cross product. Then we're just going to divide by this number here because that's going to be in our equation. That's what we'll have to divide by to solve our equation. So cross multiply and divide is really a shortcut. The process is really cross multiply, set them equal in an equation, and solve the equation. But there's a few extra steps there compared to just cross multiplying and dividing. So we could end up with something like this, we could cross multiply and divide as a shortcut, but technically the way to solve it is this. 4 times 27 is 108. X times 36 is 36x. And those two cross products have to be equal. 36x has to equal 108, and then you divide by 36. Equals 3. Like I said, you can cross multiply and divide. 4 times 27 divided by 36 is going to give us the 3. We know that. But not all proportions allow us to do that simple shortcut of cross multiply and divide. We run into proportions that might look like this. These two are A's, and that's a 9, by the way. My handwriting is sloppy. I realize they look kind of the same. I can't cross multiply and divide here, can I? Because I have two variables. Well, the variable appears twice in two different spots. But I can just cross multiply. 4 times 9 is 36. A times A is A squared. And so we can set those equal. A squared equals 36. Then we have to square root it. Very good. Now you have to be careful here. A equals 6 or negative 6. Whenever we solve an equation with a square root in it like that, and we get those two answers, we have to double check if both answers work. Would this work? Does 6 over 4 equal 9 over 6? Yeah, 6 over 4 is 1.5, 9 over 6 is 1.5. Does negative 6 over 4 equal 9 over negative 6? Yeah, negative 6 over 4 is negative 1.5. 9 over negative 6 is negative 1.5. It does equal. So they are both valid answers to this.
But not always.
Sometimes they don't. In a proportion, it usually works out because you got negatives on both sides. But in equations, there are sometimes in an equation where the negative result of the square root will not work. There are sometimes where the negative result of the square root is what you want, and the positive result doesn't work too, by the way. How about something like this? Perfect. We just have to cross multiply. 3x plus 1 times 11 is 11 times 3x plus 1. 8 times 4x plus 2, well, 8 times 4x plus 2. And we have to set them equal. It doesn't matter really which one we put first. Eight times 4x, 32x. 8 times 2, 16. That has to equal 11 times 3x, 33x, and 11 times 1. And then we solve. We have to get rid of one of the x's. We usually get rid of the smaller one, which is the 32x. That's gone. Subtracting 32x on the other side. We're left with just 16 here. 33 minus 32 is 1x, or just x, plus 11. And then subtract 11. 5 equals x. And that'd be all. What do you think? Better than sharp stick in the eye?
You gotta come up with a name. Sharp stick in the eye.
So, in that same packet, page 228, Bruce has some of these done already, but I'll have you do 17 through 40. 17 through 40.